Hello everyone, this is Sai Praneeth from Tribly. Today my topic is conducting polymers. Conductive polymer. Conductive polymers are more preciously intrinsical conducting polymers, shortcutly ICPS, or are organic polymers that conduct electricity. This is the definition for the conducting polymers. Such compounds may have metallic conductive or can be semiconductors. The biggest advantage of conductive polymers is their processability, mainly by dispersion. So here we have the flow chart or a circle chart about the conducting polymers. In the top we have the structures, and next we have the synthesis, and next we have the physico-chemical properties, and next engineering, and next drug delivery systems, and next biosensors, and next future prospects, and in the mid we have the conductive hydrogeas. This is a chart about the conducting polymers. And next we have the mechanism about the conducting polymers. The mechanism of electrical conductive of conducting polymers is based on the transmission of polarons and bipolarons. The synthesis of conducting polymers can be accomplished by electrochemical polymerization, which is more straightforward than traditional chemical synthesis. So mechanism of the conducting polymers is very straightforward comparing to the today's trending and traditional chemical synthesis. Next we have the synthesis. There are two main methods used to synthesize conductive polymers: chemical synthesis and electro copolymerization. We have two methods to synthesize any conductive polymers, and the first one is electro copolymerization and the second one is chemical synthesis. And let's see the first one. The chemical synthesis means connecting carbon carbon bond of monomers by placing the simple monomers under various conditions such as heating, pressuring, light exposure and catalysts. And we have the flow chart about the conductive polymerization or conductive polymers. In the first we have the chemical synthesis examples. N bond, like the sentence we have N carbon carbon bond. We can see the carbon carbon bond, and this is about the conducting polymers. And next we have the properties of the conductive polymers. Conducting polymers are extensively studied due to their outstanding properties, including tunable electrical property, optical and high mechanical properties, easy synthesis and effortless fabrication, and high environmental stability over inorganic materials. And we have the function of conducting polymers. This is mostly important to know about the conducting polymers. So let's see. Highly conductive polymers are used as electrode materials for supercapacitors like PANI, PPY and PTH. Conducting polymers always store and release charge through redox processes. When oxidation occurs, ions are transferred to the polymer. When reduction occurs, the ions are released back into the solution. And next we have the conducting polymers new arena in dye synthesized solar cells. So dye synthesized solar cells, we will call it in the shortcut as DSSCS, uh, have have a rose to be a cost effective substitute for solar cell in energy storage application. This is due to its special feature that as such as environmentally safe and stable, inexpensive manufacturing and simple fabrication technique. Although DSSC possesses high efficiency in power conversion, some of the material used leads towards its limitations. For instance, the use of platinum metal as counter electrode is highly cost and it extend towards corrosion. Makeover, the used of violet liquid or as electrolyte often result in leakage and low chemical stability. In order to overcome these drawbacks, uh, conducting polymers CPS are employed as replacement material for counter electrode and liquid electrolyte. So, since CPs is known with their numerous unique properties in various applications. And the next point is this overview highlighted the role of CPs, especially polyaniline PANI and polypyrrole PPY in DSSC that can improve its photovoltaic performance, dispute the challenges and future prospects in using CPs as substitute material. And next we have the chat about the conducting polymers. In the first in the chat we have 5 types, and the first type is super capacitor and catalyst, biochemical and sensors and pneumocoding. And we have the polyacetylene. The first polymer which with significant conductive synthesized was polyacetylene. Its electrical conductivity was discovered by Hideki, Alan Hager and Alan McDiarmid, who received the Nobel Prize in Chemistry in 2000 for this discovery. For creating the polyacetylene, scientists like Allen and Hager and also Hideki, they are received Nobel Prize in the chemistry in the year of 2000. They received the Nobel Prize. And the polymer as conductive material. Let's see about the polymer as conductive material. Polymers have long been known as insulating materials and are often used in cables and electrical devices. The electrical conductivity of these polymers is based on the presence of conjugated double bond along the polymer backbone. So, we can know about the polymers as conductive materials. In this, we have long been known as, we know that insulating materials are also used in cables and electrical devices also. These polymers are used in the electrical devices like phones, mobiles, chargers and many electrical devices. and these are used in also cables, also different types of cables which are optical and non-optical also. And this is all about today's my topic, conducting polymers or conductive polymers. Thank you for giving this wonderful opportunity. Thank you very much.